Okay, so today we're going to look at a topic called partial fractions. It's in the first chapter of the Year 13 book. But before we do that, we're actually just going to recap on something that we did back at GCSE, which was simplifying algebraic fractions. And at GCSE, we might have had a problem that looked like this one. So 2 over x plus 3 plus 4 over x minus 2, and we've got to write that as a single fraction. And as we know, going back to year 7 and 8, how would we add even basic fractions like 3/4 plus 2/3? The rule is always the denominators have to be the same. And it was exactly the same when we did algebraic fractions. So how do I go about making the denominators the same? Well, I want to make my denominator x plus 3 multiplied by x minus 2, because then they've got both factors in there. So let's look at this first fraction. What do I have to do to the 2 over x plus 3 to make the denominator x plus 3 times x minus 2? Well, I've got to times it by x minus 2. And with equivalent fractions, whatever we multiply the bottom by, we have to multiply the top by exactly the same. So I have to do the same to the top. Looking at the second fraction, again, I want to make that denominator x plus 3 times x minus 2. So I've got to multiply this denominator by x plus 3. And again, whatever I multiply the bottom of my fraction by, I have to multiply the same to the top. So what I actually ended up with was 2 lots of x minus 2 add 4 lots of x plus 3. Okay, so that's what I could do to simplify the fraction. And at that point, I would have expanded the bracket. So I'd have said, well, that's 2x minus 4, doing that expansion, plus 4x plus 12, doing the second expansion. And my denominator would stay as my two factors. And so I'd have had the answer of 6x plus 8 all over x plus 3 and x minus 2. Okay, so a quick recap. Now, at A level, what we actually need to do is do the reverse. So we actually need to take a single fraction and split it into its 2 or sometimes 3 separate fractions. And this is called splitting a fraction into its partial fractions. So if I look at the fraction I've got here, I've got 3x plus 4 over x plus 1 times x plus 2. So I hope you can see without too much difficulty that the two fractions that would create this, one would have had the denominator x plus 1 and the second one would have had the denominator x plus 2. So effectively, we've got to work out what value goes on the top of both these fractions so that when I combine them together, I get the fraction on the left-hand side. And the way we do this is we say, well, we don't know what those two values are at the minute, so I'm going to call them A and B. And now I'm effectively going to do what I did 2 seconds ago on this side of the fraction. So on here, I am going to try and turn this to look into that. And how did I do it? Well, what was always the rule? You've got to make the denominators the same. So I multiplied this denominator by x plus 2, which means I had to multiply this numerator by x plus 2. Again, I'm going to do the same to the other fraction. So I need to multiply its denominator by x plus 1. And therefore, I've got to multiply its numerator by x plus 1. And then I can write 3x plus 4 over x plus 1 times x plus 2 is exactly the same as a times x plus 2 plus b times x plus 1 all over x plus 1 multiplied by x plus 2. Because I just combined those fractions together, just like I did in the previous example, just like I did here. Only in this case, I've got a letter A and the letter B. Okay, now actually I'm trying to solve an equation here because I'm trying to work out what the value of A and B is. So we can actually multiply through by x plus 1 times x plus 2, and that then eliminates the denominators. So what I've now got with my equation is 3x plus 4 is a times x plus 2 plus b times x plus 1. Now logic would say I'm going to expand the brackets. So I am going to show you this method, but this isn't the method we use, but I am going to show it to you. So let's carry on how we would normally think to do this. So I'd have ax plus 2a plus bx plus b. And I'm going to collect the terms together. So 3x plus 4 would be ax plus bx plus 2a plus b. Now, if we did it this way, my number of x's is 3. So that would mean a plus b has to be 3 because I need 3 x's. So ax plus bx has to make 3 x's. And equally, I hope you can see that the number 4 has to come from this 2a plus b. So I could write 2a plus b equals 4. And now I've got a pair of simultaneous equations, okay? And hopefully you can see quite a simple pair of simultaneous equations. If I do equation 2, take away equation 1, I'd get a equals 1. And in that case, using equation 1, my b must equal 2. So what I would prove is that my a was the number 1 and the b was the number 2. Okay, so I'd have 1 over x plus, I can't remember what it was, x plus 1 plus 2 over x plus 2. And that's what my partial fractions would be. So my 3x plus 4 would over x plus 1 times x plus 2 would be exactly the same, would be equivalent to 1 over x plus 1 plus 2 over x plus 2. And this is where I always tell my pupils, especially with the easier ones, to check. So I'd have 1 lot of x plus 2 plus 2 lots of x plus 1. So that's going to give me 3x plus 4, take. Okay, right. But I'll be honest, we don't tend to use that method. I'm going to go all the way back. So actually on the side, I'm going to write what my answer was. So I had A was equal to 1 and B was equal to 2. And I'm just going to leave it over there because hopefully, well, this second method should give us the same answer. Okay, and it's basically an easier method. And what we actually do is we say, okay, I've got this equation here. But actually, if I substituted in a number for x, I could make this quite clever. And I could eliminate one of my letters A or B. And I'm going to show you, so hopefully that helps you understand what I'm saying. I'm going to say let x equal the number minus 1. And you'll see why I've chosen the number minus 1 in a minute. So let's substitute x equals minus 1 into this equation. So 3 lots of minus 1 plus 4 on the left-hand side is equal to A times minus 1 plus 2 in the bracket plus B times minus 1 plus 1. Right, hopefully you can see that last term, B times minus 1 plus 1. Well, minus 1 plus 1 is 0, so that effectively disappears. So what we're left with now is just an equation where the only unknown thing is the letter A. So let's work out the left-hand side. Minus 3 plus 4 is 1. Let's work out what's inside the brackets next to the A. Minus 1 plus 2 is 1. So I've got 1 equals 1A. So guess what? A equals 1. Right. Let's look at a different number to substitute for x. So this time, Again, I'm changing the colour just so we can distinguish the bits. Let x equal, and I'm going to choose the number -2. Now I hope you're starting to think, why is she using that number -2? And you'll see. So again, substitute it into the left hand side. So 3 lots of -2 plus 4 is equal to a bracket -2 plus 2 plus b bracket -2 plus 1. And again, I chose that number because if I look at that bracket next to the letter A, -2 add 2 makes 0. So now that one disappears. So that term has totally gone. And now I'm left with the equation just in B. So 3 lots of -2 is -6 plus 4 gives me -2 is equal to B times, well, -2 add 1 is -1. So effectively we've got -2 equals -B, multiply through by -1, and therefore B is equal to 2. And as you can see, I've got exactly the same answer. But in a way, I didn't have to solve simultaneous equations. I just had to substitute 2 different numbers of x. So we ended up with our final answer, which was 3x plus 4 all over x plus 1 multiplied by x plus 2 is equal to 1 over x plus 1 plus 2 over x plus 2. Okay. I will do this other example now. So again, this time I've just got 5 over x minus 1 multiplied by x plus 3. So again, hopefully you can see that would come from the 2 fractions, a over x minus 1 plus b over 2x plus 3. So we take that right hand side, we simplify it. What am I going to have to do? I'm going to just do this nice and quick. So the 2 numerator and the denominator is going to have to be times by x minus 1. The numerator and denominator are going to have to be multiplied by 2x plus 3, okay? And you end up with 5 over x minus 1 times 2x plus 3 is equal to a times 2x plus 3 plus b times x minus 1 all over 2x plus 3 times x minus 1. And again, at this point, these denominators cancel because I can multiply through the equation by x minus 1 and 2x plus 3. So what am I left with? 5 equals a times 2x plus 3 plus b times x minus 1. Right, I'm going to give you a second. Think about what value of x you think I should use. And I'm going to do the easier one first. So hopefully you've thought I would use, I would use x equals 1. And that is so that I can make this bracket 0. So if I use the substitution of x equals 1, I get 5 is equal to a, 2 lots of 1 plus 3, plus b, 1 minus 1, and that disappears. So I've got 5 is equal to, well, 2 lots of 1 plus 3 is 5, so I've got 5 is equal to 5a, so a is equal to 1. Now these answers for a's and b's are not always whole numbers. Sometimes they are fractions. More often than not they are whole numbers, but you can't guarantee it. Sometimes they might be a half or a third, and occasionally they will be quite nasty fractions as well. Okay, right then, let's think about the second value of x that you're going to use. This one's maybe not quite as obvious, but what you've got to think to yourself is, with this second value of x, I want to make this bracket, sorry, I changed the colour, I need to make that bracket 0. So how would I make that bracket 0? So I could think, I want to make the bracket 2x plus 3 equal to 0. So 2x must be minus 3, so my x must be minus 3 over 2. So that's the substitution I'm going to use. So I'd have 5 equals a bracket, and I'm going to write this in just because I know it's going to be 0, but I want to illustrate it. So I've got a times 2 lots of minus 3 over 2 plus 3 plus b times minus 3 over 2 minus 1. Okay? We know this a bracket is going to be 0. We know it because that's the value of x that we chose to make that bracket 0. So I'm left with 5 equals b times, well, minus 3 over 2 take away 1 is minus 5 over 2. So hopefully we've got 5 equals minus 5b over 2. They're going to cancel. 2 is going to go up there. So my b is equal to minus 2. So you should always write this final line down. Never leave it as just writing down what the a and the b is. So our final answer is 5 over x minus 1 times 2x plus 3 is equal to, just make sure I get this the right way round. So I've got 1 over x minus 1. And I don't write add minus 2 over 2x plus 3, because we all know adding a negative is the same as taking away. So what we tend to write is take away 2 over 2x plus 3. Okay. Right. Final 2 examples I'm going to show you is sometimes it might not be obvious what to do. And so it might say split the fraction 8 over 8 x squared minus 4 into its partial fractions. And what you've got to realise is that that is actually x plus 2 times x minus 2. And so your partial fractions would be a over x plus 2 plus b over x minus 2. Okay, I'm not going to carry on with that, but that's what you'd have to do. And something like this one, where it's got 2x plus 1 over x squared plus 3x, again, you've got to think about what's this denominator going to become. And the denominator could be factorised into x multiplied by x plus 3. So in this case, you'd have a over x plus b over x plus 3. Okay? And actually, I will do this one now. So again, you'd have to think, I need to times the top and the bottom to make the denominators the same. So I'd get my 2x plus 1 equals a times x plus 3 plus b times x. Now, if you notice on this one, I didn't bother to write the denominators down because I know I'm going to take the step where I'm going to then eliminate the denominators. So as here, I knew at this point I was going to eliminate these two denominators. When you get a bit faster, you realise you don't have to write that stage in. You can just write that 2x plus 1 is a times x plus 3 plus b times x. And this is quite a nice one. I like it when it's like this because the first one is I say let x equal 0 because x equals 0 is going to get rid of that b term. So I get 1 is equal a times 3. So my a is 1/3. And then the second one, I'm going to say let x equal minus 3 because I want to get rid of that a term. So 2 lots of minus 3 plus 1 is minus 5 equals, the a term has gone because minus 3 plus 3 is 0. So I've got minus 3b. So therefore, b is equal to 5/3. And the reason I wanted to show you this one was because the best way to write this down is then to write, sorry, I'm trying to remember what this is, 2x plus 1 over x squared plus 3x. Now you could write it like this. You could write 1/3 over x plus 5/3 over x plus 3. But that's not really very nice, okay? So let's think about what this means. Let's think about what a over x means. Well, a over x means a times 1 over x. And we've just decided that a is 1/3. So 1/3 times 1 over x. A nicer way to write that would be to write it as 1 over 3x. Let's do the b over x plus 3. Well, I could write that as b times 1 over x plus 3. And I've just discovered that b is 5/3. So 5/3 times 1 over x plus 3. A nicer way to write that would be 5 over 3 bracket x plus 3. Okay? And that's a much nicer way of writing it when you have a fraction. Okay, I've just given you 3 to do. First one, straightforward. Second 2, you have to factorise your denominators first to work out what your 2 partial fractions are going to be. Press pause, have a go, and then I'll show you the answers in a second. Okay, so number 1, fairly straightforward. You should have got that a was -1. For the second substitution, you want to make that 2x minus 3 equal to 0. So your second substitution needed to be x is 3 over 2. If you did that, you got b was equal to 4. So you ended up with 2x minus 1 over x minus 1 times 2x minus 3 is -1 over x minus 1 plus 4 over 2x minus 3. Or you could have wrote those the other way round and done it like that. Okay. Number 2, when you factorise that bottom, the way you do it is you take out a factor of x. So you end up with x times x minus 1. Okay, so then you do your partial fractions. First substitution I did was x is 0. I got a nice a equals 3. Then I let x equal 1 and ended up with b equals -2. So my partial fraction was 3 over x minus 2 over x minus 1. And the final one, factorise the denominator, and you got x plus 5 and x minus 3. So they're your partial fractions. Use the first substitution of x equals to 3, which eliminated the a term. You got b equals -1. Then use the substitution x is -5. That eliminated the b term, and you got a equals 3. And so you ended up with the partial fractions 3 over x plus 5 minus 1 over x minus 3. Okay, so final step in today's lesson is sometimes they will give you 3 partial fractions. Okay, so in this case, I write a over x plus b over x minus 1 plus c over 2x plus 1. So there's 3 fractions that are going to combine to make the 1. And this is where it's a little bit more complicated, and these are the more typical questions that you get at A level, because I need to make the denominators the same. And my denominator has to have all 3 factors. So for this first one, I have to multiply it by the other 2 denominators. So I have to times it by the x minus 1 and the 2x plus 1. And if I do that to this denominator, guess what? I've got to do it to this numerator. Right, let's look at the second fraction. I need to multiply this by the x and the 2x plus 1 because that denominator's got to have all 3 factors. So guess what? I've got to do it to the numerator because whatever you multiply the denominator by, you have to multiply the numerator by the same. And then the final one, again, I've got to make this denominator have all 3 factors. So I've got to times it by the x and times it by the x minus 1, which means I have to multiply the numerator by exactly the same. And again, at this point, I'm going to say these denominators now all cancel out. So what am I left with? I am left with 6x squared plus 5x minus 2 is equal to, right, a times x minus 1 and 2x plus 1 plus b times x and the 2x plus 1 plus c times the x and the x minus 1. Okay, which at this point you're thinking looks quite horrific, but actually it turns out to be quite nice because we use exactly the same process. And we think we're going to substitute a value of x, and I need to choose my values of x so they eliminate a bracket. So I hope you can see with this one, if I choose my value of x as x equals 1, this is going to equal 0, and the c term is going to equal 0. So let's do it. So I've got 6 times 1 squared plus 5 lots of 1 minus 2 is equal to, well, my a term goes, because I'm going to have that 1 minus 1 in that bracket, and anything times 0 is going to be 0, plus b times 1 times 2 lots of 1 plus 1, well, they're not going to disappear, plus c, and again I'm going to have that 1 minus 1, so that's going to disappear. So actually, by choosing x equals 1, I've eliminated the a and the c. So all I'm left with is the b. So I've got 6 plus 5, take away 2. I've got 9 on the left hand side, and I've got 3b on the right hand side, because this is 3 and 3 times 1 is 3. Therefore, b is equal to 3. Okay? Be careful, it's really easy to sometimes write these down as a third or 3 or 2 instead of a half, or a quarter instead of 4. When you're doing these quite quickly, you can quite easily make these silly mistakes, so be really careful with these, okay? Right, so next letter I'm going to substitute, or next value of x I'm going to substitute. I'm actually going to make my x equal to 0, because I want to get rid of this one and this one. So I'm going to say x is 0. With this, 6 lots of 0 squared plus 5 lots of 0 minus 2 equals a times 0 minus 1, 2 lots of 0 plus 1, plus b times 0, so that's going to go, plus c times 0, so that's going to go. Okay, so I'm going to get minus 2 equals, that's minus 1, 2 plus 1 is 3, so we're going to have 3, oh no it's not, sorry, is 1, because 2 lots of 0 is still 0, making the classic mistake there. So I get minus 2 equals to minus a, therefore a equals 2. Okay, and then the last one, all I've got to do now is think, how can I make this bracket and this bracket equal to 0, so that then I can eliminate the a and the b. So I want to make 2x plus 1 0, so that means I need to use a substitution, x is equal to minus a half. Okay, so I'm going to have 6 times minus a half squared plus 5 times minus a half minus 2 is equal to, well, we're going to have the a times 0, so that's going to go. We're going to have the b times the 0, so that's going to go. So then with the c, we're going to have c times minus a half and minus a half minus 1. Okay, so I'm going to have to sort this out. So, I must admit, I'm going to put this into my calculator now. She says, grabbing a calculator nice and quick. And I've got to be honest, that's probably what I would do. So I've got 6 times, well, minus a half squared is a quarter. Minus 5 over 2 minus 2 is equal to, so the left-hand side becomes minus 3. And then I've got minus a half times minus a half minus 1. That's minus 3 over 2. So that's going to become over 3/4 c. And so that will cancel with that. So c becomes minus 4. Sorry about that. That's my phone. Right. So I've got my A, my B and my C, and then I could write it in. I've run out of space, so I'm going to have to do it up here. So I had A was equal to 2. I had B was equal to 3. And my C was equal to -4. Okay. The only other one to watch out, I'm not going to do this one, but to make you realise, you have to factorise your denominator. If I take out a factor of x first, I get x squared minus 1. But then remember, what is this x squared minus 1? It's a difference of 2 squares. So it would become x plus 1 and x minus 1. So I'd have a over x plus b over x plus 1 plus c over x minus 1. Okay, I will do that one and put it in the final solutions that I put on Edmodo, but hopefully you can see it's exactly the same process. Okay, so I've got 4 for you to do. Press pause, have a go. The one thing I will say about number 5 is the fractions are quite awful on that one, so don't think necessarily that you've gone wrong. Okay, it's just the numbers are quite nasty, but hopefully have a go. And the hints for 6 and 7 is remember to take out that factor of x first, okay, from your denominators. Okay, so press pause, have a go, and I will show you the solutions when we're finished. Okay, so number 1, we use the substitution x equals -1, x equals -2, and x equals -3, and hopefully you got the answer. 2 over x plus 1 minus 1 over x plus 2 minus 1 over x plus 3. Okay, like as I said, with this one you got quite horrible numbers because you needed to use substitution x equals 2. So you ended up with a was 7 over 40. You had to use x is -6 and got b was 7 over 24. And x was -3. And you got c was -7 over 15. And so you ended up with that quite horrible looking answer there. Right, number 6. So again, you had to do that. Take out that factor of x from the denominator first and then work out what the 2 factors of that quadratic was. So your partial fractions were a over x plus b over x plus 3 plus c over x plus 1. Should have worked them out and got that solution hopefully. And finally, number 7. Again, take out that factor of x from the denominator first, and then you've got a difference of 2 squares. And you should have had nice numbers this time. 1 over x minus 1 over x plus 4 plus 1 over x minus 3. Okay, the big thing about these is to practice, practice, practice. Okay, they are quite laborious. It is quite methodical. You do follow a bit of a process, but they are really, really easy to make mistakes on. So the best way to combat that is to do lots of examples and do lots of practice. There's the questions from the book, and we are going to set a worksheet on top of that for you to have a go at as well. Okay, thank you.